Okay, so if you're starting to understand the chain rule, you probably don't need to copy out the first set of rules, but this is what we're going to focus on today is, rather than power rule, which was a lot of what we did yesterday, we're going to look at things like sine, cosine, tangent, e to the x, all that kind of stuff. So just to give you an idea what I mean by you don't necessarily need to copy all these in, this would be like my outside function here, and this would be like my inside function there. So it's the derivative of the outside times the derivative of the inside. So again, if you feel it's useful, you can copy those in to refer to them, but otherwise, if you're getting the hang of the chain rule, it's probably not necessary. So today when we're talking about the chain rule and who the inside function, the outside function is, we're probably going to want to think about order of operations. So when we get there, I'll give you a minute to write it down. That's what we're going to ask ourselves, is which function would have to be calculated first. Okay, so I'll give you a minute and then we'll come back. Okay, so let's take a look at the first example here. Applying the chain rule to the sine of 2x. So there's two things happening here. One is the sine. So we're looking for the sine of something. And we're also looking at 2x. So which one would have to be calculated first?
2x.
Yeah, before we could take the sine, we need to know what number we're dealing with. So we'd have to do 2x first. So this would be the inside function, and this would be the outside function. So if I wanted to differentiate it, derivative of the outside is going to be cosine 2x. The derivative of the inside is 2. So this would be the derivative for the first piece. So I'm going to let you try the next couple on your own, and then we'll try to catch up together. See if you can, with a neighbor, maybe chat about which one comes first. Who's the inside, who's the outside? Okay, so for the first one, let's talk about this. Cosine or x minus 1? Which one's inside, which one's outside? Slow down, not all at once.
Cos is outside.
Cos is outside, and x minus 1 is inside. So to do this derivative, it would be negative sine of x minus 1 times the derivative of the inside, which is 1. Okay. Now how about e to the 3x? Which one would you have to do first? 3x would be first. So the inside is 3x. The outside is the exponential function. So the derivative of my favorite function is my favorite function. The derivative of the inside is 3. Now the next one, the next three are just to clarify. I know we talked about this in Math 12, but this is to clarify some of the notations. Okay, so in the first example, this is like 3x squared. In the next one, this squared only affects the brackets. Okay, and in the last one, this would be like the cosine of x all squared. Okay, so that's consistent with what your textbook will use as well. So just want to make sure that you guys don't confuse all three types of, where the exponents may appear. So try those three just to get a hang for those notations together. In the first question, the outside is going to be the cosine. So this would be a negative sine of 3x squared. Then the derivative of the inside is going to be 6x. Okay. The second one, you may want to think of this, it's probably easiest if you think of this as 9x squared. That's probably the easiest way to do it. It's possible to do it the way it's been presented, but it means you'd have to use chain rule twice. So we haven't talked about that yet. We will very shortly, but this is probably the easiest way to start it. We'd have negative sine of 9x squared. Derivative of the inside is 18x. Sorry, thank you. Just testing to make sure you're awake. So, and then the last one, this is going to be the exponent 2 times the cosine of x to the 1 times the derivative of the inside, which is the negative sine. Okay, so it is possible, and you will be expected to recognize when the chain rule is going to happen more than once. So for example, in this next situation, the sine cubed of 4t, let's just see if we can identify that there's actually 3 functions here. Okay. Can you tell me what those three functions would be that I have to deal with for the derivative?
Sine 4t.
So you just said two of them. Sine is one of them, 4t is another, and the cube is the last one. So there's actually three functions there. So what we're going to do is we have to figure out, okay, who's outside, middle, and inside. We have to figure out which order these would be applied. So what do you think, order of operations wise, who's going to come first? There's no harm in rewriting this. Some of you may find it easier to think about if we rewrite it as sine 4t cubed. They're the same thing. But what do you think? Before I do any of those calculations, who has to know the answer first? 4t has to know the answer. It will tell the sign, right? Sign can't ask for it until 4t has figured out what that number is now. So the first thing is 4t. Okay? Once 4t knows its answer, it can tell it to sign. So the second one is the sign. And then the third one, the last, will be the cube. Okay, so if I put these pieces together, this will be, like, as I said, the inside, the middle, and the outside. And we may possibly have to do it 4 times, but we would still, hopefully be able to identify all the pieces. So let me show you the way this works. There's a couple ways we can do this. When you're getting used to it, it's not a bad idea to think about it like this. Let's go nice and slow. Let's just do the chain rule one at a time. So the derivative of the outside would be 3 sine 4t squared times the derivative of the sine of 4t. Okay, so that's the chain rule, right? But we're not finished because there's still a derivative here we haven't taken. So let's go again. The derivative of sine 4t, that's the cosine of 4t times the derivative of 4t. That's the chain rule, but we're still not finished. There's one more derivative there. The derivative of 4t, that's 4. So here are the pieces. 1, 2, 3. All 3 pieces make up the complete derivative. So for example, I would write this out as 3, sorry, that would be a 12 once I put those two together. So 12 sine 4t squared times the cosine of 4t. Now, there's nothing wrong with doing it a fast way, and I'll show you a faster way to do it, but generally when you start out with chain rule having to do it multiple times, this way is helpful because it tells me who's next in the chain, right? I did one function, and then there's the chain. Who's next? Okay, one function here, there's the chain. There's only one function now, so there's nobody left. So it kind of tells me who's left to keep taking the derivative of. As you get more comfortable, just like when we've done other chain rule stuff, you don't need to do this whole thing right from the top like this. I'm going to erase this. Is it, everybody had a chance to copy it? Any last? Okay. So it is also possible for you to recognize that there are 3 pieces here that we've just talked about, and you could say it's the derivative of the outside times the derivative of the inside, which would be cosine 4t, then apply the chain rule one more time. But people tend to forget that last piece when they go too quickly. That's why I suggest that you do it piece by piece. Okay, once you get the hang of it, you're up to your own discretion as to how you like to approach that question. We will practice more today about multiple chain rules. But anyway, for now, let's get our last item up for
That's the final
to know.
answer?
Yeah, that's the final. Well, it would be 12
Yeah, we did that 12 one.
because it's 3 times 4 here.
Oh, okay.
Right, so that was where 12 came from in the last one. 3 times 4. Okay, so here's our last thing that we're gonna. Shall I say? No, there's more rules, but this is our last major rule in the differentiation, which is the natural logs derivative. So I'll tell you right away that the derivative is going to be 1 over x and then I'll show you how we can do that. So again, this is our one proof of the day. If you're not the kind of person who's really cool with proofs, that's okay. Try to follow along. You don't need to copy it into your notes. But again, next year it's going to be a reality for some of you, so you're going to want to try your best to keep up and follow along. So again, we're going to go to definition, which is the limit as delta x goes to 0. And it's going to be the natural log of x plus delta x, take away the natural log of x, all over delta x. So I have to figure out how to get this to look like 1 over x. Now, we ought to start manipulating this. And there is a rule that we talked about before that I'm going to use here from Math 12. And it looks like this. Okay, so that was one of the log laws that we talked about. Hopefully it's still semi-familiar to you. And it's going to be more convenient for you to see where this starts to come from if I rewrite that fraction. Instead of having that fraction, I'm going to rewrite it as this one, the natural log of 1 plus delta x over x. And it's not obvious to, I would say, to just about anybody, unless you're really quick with calculus and you're an expert at it, right? Proofs. The first person to prove this stuff, remember, they're going to be like the world's expert because no one else has figured out how to do it yet. So once they've figured out how to do it, we can learn a lot from them. But, you know, they're looking at this trying to say, how can I change this? And one thing that you might not recognize here, because we're still new to calculus, this looks like a special limit in here, and that's what I'm going to try to change it into. Any guesses what that special limit might look like? Okay, I'll see if you recognize it as I change it. So one thing I'm going to do to make it look like that special limit is I'm going to say let u equal delta x over x. If that's true, then u times x equals delta x as well. And as delta x goes to 0, okay, that means u must also go to 0 in order for them to be equivalent. So I'm going to rewrite this limit as u goes to 0 of natural log 1 plus u over ux. Okay. And instead of dividing by ux, I'm going to use log laws again. So I'm going to move this to the front. And really, this is like two fractions. So I'm going to write it like this to make it more convenient for us. It's going to be 1 over u times 1 over x. And the log law says I can move that multiplication up as an exponent. So it's going to look like this. So now, does anybody recognize that limit? Of course you don't. Do you? Does anybody? I probably wouldn't recognize this if I hadn't done this before, so don't sweat it. This is the special limit we've talked about. This is the limit e. So what happens then as u goes to 0, this is unaffected. It's just 1 over x times the natural log of e, which is 1. Okay, so it's a little bit tricky there in order to figure out how to make that switch to get that special limit e to appear.